Hello, we're going to pick up where we left off in the last video by using these log properties to solve some log equations. I'm not going to start by just using a base to cancel the log because I have log written twice. I will get back to that though. What I'm going to do first to make things a little simpler is use my log properties to rewrite this as something with just one log. So we're going to be moving from the right-hand side of the equation to the left-hand side of the equation for these. I got rid of our power rule because we're not going to end up using it and because I need the space to write things. We're going to be focusing on just product rule and quotient rule to help us with these today. So let's take a look at it. First thing we're going to do is rewrite this using our properties. I have addition of two logs here. I know addition can be turned into multiplication. So I'm going to rewrite the left-hand side as log base 6 of first argument, which is 7, times the second argument, which is 2x minus 7. The equals 2 stays the same. We don't need to change anything there. If you didn't have the log here, your gut would be telling you next, hey, I need to multiply or distribute these. That's exactly what you're going to do. We're going to leave the log there because we haven't canceled it yet. But we're going to distribute. When we distribute that 7, we get 14x minus 49. The equals 2 also stays the same. Now this looks more like things we did in the previous lesson. To get rid of this log base 6 or cancel it out, I'm going to use a 6 base here. Anything I do to one side, I have to do to the other. 6 and log base 6 cancel. So I get 14x minus 49 equals, remember this is 6 squared, which is 36. So this side of the equation becomes 36. What we have in purple looks like equations we've been solving for a long time. Get x by itself. So add 49, and then divide by 14. We get a fraction, that's okay. X is 85 over 14, or you can convert that to a decimal if you'd rather. This one is also addition, so we are going to follow the same process. We're going to start by turning the addition into multiplication. So when I do that, I write my log just once, which is log base 2. And I need to multiply these two things together. 3 minus 5x times 6. I need to distribute here. So log 2 stays the same. When I distribute the 6, I get 18 minus 30x. Next up, we need to cancel log base 2 by using a 2 base on both sides. 2 and log base 2 cancel each other out. 2 squared, or 2 to the 2 power, is 4. Now solve it like you would any other equation. Get x by itself. Very last step here will be divide both sides by the number in front of x, which is negative 30. You get a fraction, but that fraction can be reduced. Negative over negative is positive. 14 over 30 reduces into 7 over 15. Again, you could write that as a decimal as well. All right, now the last two, instead of addition, we have subtraction. We know subtraction can be turned into division, so that's exactly what we're going to do. When I turn this into division, I write my log just once, log base 3. First argument goes on top, second argument goes on the bottom, equals 2. Now I can't distribute or anything like I did here, so there's nothing I can do to simplify inside that fraction. My next step here is to get rid of the log by using the base. 3 and log base 3 cancel, so I get fraction stuff equals 3 squared, which is 9. It's been a while since we've solved equations that look like this. In order to solve this, the first thing I need to do in the green equation is to get rid of that divided by 8 by multiplying both sides by 8. When I do that, the 8's cancel, but the top part of the fraction stays the same. Other side, 9 times 8 is 72. And then I solve it out from here. I'm going to continue it off to the side here because I ran out of room. I end up with 3x equals 63. To get x completely by itself, I divide. And I get x equals 21. Very last one's going to work incredibly similarly. It is also division, so we know we need to turn the left-hand side into a fraction. We write our log just once. First argument goes on top of the fraction, second argument goes on the bottom, whole thing still equals 1. To undo log base 8, we do an 8 base on both sides. So I'm left with fraction stuff equals 8 to the 1, which is 8. And then to solve that green equation, undo dividing by 3 by multiplying both sides by 3. And then solve for x. So to solve for x, I'm going to add 9. And last but not least, divide by the number in front of x. We're going to get a fraction, and that's okay. Final answer for this one is -33/2, which again you could write as a decimal. So when you see log happening twice on the same side of the equation, use your properties to rewrite it to where it turns into just one log, condensing it if you will. And then from there, use your exponentiation to cancel the log, and then solve the equation like normal. That's it for this lesson. Have a fantastic day.